So this worksheet is all about finding or determining the domain and range when just given a graph. What I do is I use a pencil or pen to aid in this. Domain represents all the possible x values in a relation or function. So what I do for domain is I hold my pen or pencil vertically and I sweep from left to right looking for where the pen or pencil touches the function or relation. Now for this one you have these arrowheads. These indicate that the function continues up forever and also on the left hand side to the left forever. So we start at negative infinity. And we'll use interval notation since these are continuous or graphs that have an infinite number of points on them. And then I sweep from left to right. I've got stuff, I've got stuff, I've got stuff, I've got stuff, I've got stuff. I have function values for any value of x. Do all parabolas have an infinite number of points? Yes, they do. But that doesn't mean that the domain is always negative infinity to infinity. Usually, you can have a sideways parabola, which is not going to have an infinite domain, so to speak. Okay? And then the range, what I do is I go from the bottom to the top, and I locate my starting point. Shout it out, what is it? Yeah, but because I'm talking about range, which one do I care about? -4. That is the lowest y value that this function has. And it's not an open circle, so I will choose a square bracket. And then I continue going up. Got stuff, got stuff, got stuff, all the way up to positive infinity. So, in other words, this function is defined for all real numbers in terms of x, but it only produces y values that are at or above -4. And hopefully you can see that. There's nothing below y equals -4. Any questions on 1? Okay, I'll call in some random people for at least a few of these. Chowan, could you give me the domain for number 2? Negative infinity to positive infinity, yes. As you go from left to right, over here at negative infinity, you have stuff, you have stuff, you have stuff, you have stuff, all the way to positive infinity. So this function is defined for all real numbers in x. And Nikki Brown, I know you're working, and that's fine. Could you just tell us what the range is for this one, number 2? Correct. We have y values down here at negative infinity, and as we go up, still have y values, all the way up to positive infinity. Another way that just came to mind is thinking of these in one dimension at a time. So for the x, we have stuff all the way from negative infinity to positive infinity. So the domain is negative infinity to positive infinity. For the y, I don't have stuff down here. I do have stuff starting at -4 and up. For this one, you have everything in both directions. Any questions on 2? Okay, Allie, could you tell us what you think the domain is for number 3? Yes, and it's not clear. It's not clear whether this is an open or closed circle. It looks like it has a little opening in it, so we'll just say it's open. It affects whether it's a bracket or a parenthesis. Okay. So if we are assuming that this is open, then it would be parenthesis. If it is closed, then it will be bracket. Okay. So parenthesis -5, comma 2 parenthesis. So in other words, this function is defined for x values between -5 and 2, exclusive on both ends. We're assuming, at least for one end. Nick, could you tell us what you think the range is for number 3? Yep. And then when you're telling me these numbers, keep in mind that you will be required to state whether it's parenthesis or bracket. So if we're assuming that this is open, what would it be, Nick? Yeah, parenthesis, -3, comma 4, what? Parenthesis. Any questions on 3? All right, Brett, for number 4, what do you think the domain is? I don't think so. I am assuming that these arrows just go straight out and not down, for example, on this lower one. So think about what x values... Oh, excuse me, Brett. I completely take back what I said. I was thinking about range. My apologies. It's Monday. So for domain, yes, you go from left to right. I've got stuff, I've got stuff, I've got stuff. Good. And Dominique, how about the range? I would start with the lower number first. Yeah. So the range goes from -5 to +4. Closed on both ends. Good. Let's do at least one more. Jessica, number 5, what do you think the domain is? Okay, so you might not be used to this type of graph. These hatch marks mean that the graph doesn't cross that line. You might have heard of the term asymptote before. This graph has a vertical asymptote. It looks like at x equals 0. In other words, it doesn't cross the y-axis. Similarly, it looks like we have a horizontal asymptote at y equals 0. In other words, it doesn't cross the x-axis. So if you sweep from left to right, we start at -infinity on the x, and then it looks like we stop at 0. Okay? So given that new knowledge, Jessica, do you think you can tell me what the domain is? Did you say 2? -infinity to 0, good. Good. Okay, -infinity to 0, union with 0 to infinity. We have 2 distinct sections here, so we have to use the union symbol. And Julia, what do you think the range is? You don't need to use a union for the range here. No, because as you notice, you don't have any y values above 0. negative infinity to 0. Okay, so as you go from the bottom to the top, I have stuff, I have stuff, I have stuff, I have stuff, and then I cease having stuff once I go past this line. Any questions on 5? Okay, before I stop this, are there any other ones that you want me to do from this worksheet?